Hi, Chapter 6, Number Pattern, Activity 1. Given the sequence two, 5, 8, and 11, 1.1, determine the constant difference. Constant difference D is T2 minus T1, which is the previous term. T2 minus the previous term. D, it's T3 minus the previous term, which is term 2. D, okay, D is the symbol for constant difference. D is equal to T4 minus the previous term, which is T3. This is T1, T2, T3, T4. What is T2? It's 5 minus 2, which is term 1, so it's 3. What is D? Is T3 minus T2, which is 8 minus 5, so which is equal to 3. D is equal to T4 11 minus 8, which is equal to what? 3. Done. You can see it's constant, it's the same, or it's common. 1.2. Determine the general formula, or they can say a general rule. Instead of formula, they can write rule. To find the general formula, this is general. Tn is equal to d n, which is d times n, plus what? Plus c. Okay, always this is the general formula for arithmetic, because this is arithmetic. So if you have constant difference, you always use this formula. You need this d. That is why the first question says determine the constant difference, because they know you will need d to find the general formula. Then you substitute your d. What is your d? Your d is 3. Where you see d, substitute 3. N plus c. You can use any term. I can use term 2 if I want to. Let's say term 2. If you put 2 where you see n, that means I have to put 2 here also, plus this c. Okay, what is term 2? You have term 2. What is term 2 now? Term 2 is 5. As you can see, term 2 is 5. You substitute term 5. If you want to, you can use term 1. You substitute 1 here, then you will use 2 here. If you want to use term 3, you can substitute 3 here and substitute 3 here, but you will use 8 under term 3. Okay, so 3 times 2 is 6 plus c. So this is 5 equals to 6 plus c. I don't need this 6. An additive inverse, you need an additive inverse. Okay, the opposite of addition is subtraction. Same number. What you do on the right hand side, you also do on the left hand side. That's 6 and that's 6, they cancel. C. 5 minus 6, it's minus 1. Then you take your c and substitute your c back in Tn. Tn is equal to 3n. What is c? It's minus 1. This is the general formula. Let's try and see whether this general formula works for term 1. If it works for term 1, it will work for all the terms. Let's test it. Term 1, it's equal to 3. Where you see 1, where you see n, you substitute 1. Where you see n, you must substitute 1, minus 1. 3 times 1 is 3. minus this one. 3 minus 1, it's 2. So there is term 1, it's 2. That means this formula is correct. Okay, you can check it for term 2. Put 2 here. 3 times 5. Term 2, it's 5. 3 times, okay. Yes, sorry. You want to check term 2. Term 2 is 3 times. Where you see n in this formula, you substitute 2 minus 1. 3 times 2, it's 6. Minus 1, the answer is 5. Do the same thing for term 3. 3 times 3, it's 9. Minus 1. 9 minus 1, it's 8. Let's try term 4. 3 times 4 is 12. 12 minus 1, it's 11. So it works. 1.3. Find T9. If you want T9, find ninth term. If they say find the ninth term, use the general formula Tn. It is equal to 3n minus 1. That is your general term formula. So if you want T9, this is going to be 3 times what? 9 minus 1. Okay. 3 times 9. You know what is 3 times 9? 3 times 9, it's 27 minus 1. 27 minus 1, it's 26. So T9 is 26. 1.4. Okay, let's not forget the general formula. General formula, it's Tn equal to 3n minus 1. 1.4. Determine the 100th term. To determine the 100th term, you know Tn. It is equal to 3n minus 1. When you see n, you substitute 100. This is what? 300 minus 1. This is 299. 1.5. Determine the kth term. The kth term will be T. You have Tn is equal to 3n minus 1. When you see n, you substitute k because you want the kth term. 3k minus 1. That is the answer. 1.6. Determine the eleventh term. The 11th term you used to Tn. Tn is equal to 3n minus 1. When you see n, you substitute 11. It's 3 times 11 minus 1. 3 times 11, it's 33 minus 1. 33 minus 1, it's 32. 1.7. Find the position of the find the position of 202. Find the position of 202. If I want to find the position, you write your general formula. It's 3n minus 1. That is your general formula. Then you need a position. If they want the position, they refer to n, they say find n. Now, this 302 becomes what now? Becomes Tn. So 302. It's 3n minus 1. This is 3n minus 1 plus 1, an additive inverse. This is 302. If you add 1 this side, you must add 1 side on the other side. This is 3n. This is 303. Divide by 3 both sides. Divide by 3 both sides. 3 goes to 303 how many times? 101. 303 divided by 3, it's 101. So the position is 101. The position of 302 is 101. 1.8. One 1.8, find the position of of 14, the position of 14, Tn, it is equal to, Tn is equal to 3n minus 1. That is the general formula. Now, when they want the position, they need n. So you substitute 14 where you see Tn, 3n minus 1. I don't need this minus 1, I must add plus 1 to cancel that minus 1. Additive inverse. What you do on the left, on the right hand side, you also do on the left hand side. You will also add this one. That and that they cancel. 14 plus 1 is 15. 3n. And I divide by 3 both sides because I need n. This is 5. So it's 5th position. 14 is on the 5th position. 1.9. Find the position of 8. The position of 8, general, and you have position of 8. You know position, the position of 8, it's in number 3. But you need to prove that using the general formula. It's 3n minus 1. What is the what is the Tn, the general term? It's 8. We need n, 3n minus 1. This is 8 equal to 3n minus 1. I need to add plus 1 because I need an additive inverse to cancel this minus 1. So I'll also add 1 on this side. That and that they cancel. It's 3n. 8 plus 1 is 9. Then I need to divide by 3. I need to divide by 3. N, 9 divided by 3 is 3. Okay. The last one. So the position is 3. As you can see, it's the 3rd position. The last one, I'll do position 1 and I'm expecting I'll do the position of 2. As you can see, position of 2 is 1. Position of 2. General term, it's Tn equal to Dn, 3n minus 1. Tn is 2 because I need position. That means this n minus 1. 2. This is 3n minus 1. Minus 1, I don't need this minus 1 here. I must add plus 1. Additive inverse. What you do on the right hand side, you also do on the left hand side. This is 3n. This is 3. 2 plus 1 is 3. Can I divide by 3 both sides? Yes. So n is equal to 1, and I was expecting to get 1. So it's position 1. That is 1.10.